Let's solve Unit 2 Computer System Architecture questions. A multiprocessor system with 16 processors is used to execute a parallelizable task. If the serial portion of the task takes 200 clock cycles and the parallel portion takes 800 clock cycles, when all 16 processors are used, how many total clock cycles are required to complete the task? When they say the task is parallelizable, it means all the processors will be fully utilized there. When they say about serial portion of the task, it means only one processor will be in use at that time. So in order to calculate the total clock cycles, you have to combine the serial portion time and the parallel portion time. So let's take the 16 processor on the whole. If you take the serial portion, it will be executed only by one processor. So let's take that to be the first processor. When the serial portion involves only single processor, what is the time that is given in the question? It is 200 clock cycles. So we have the serial time is equal to 200 clock cycles. What about the parallel portion? When you take the parallel portion, all the 16 processors will be involved and the total time that is given for the parallel portion will be 800 clock cycles. When we say the parallel portion is executed by 16 processors at a time, it takes 800 clock cycle time. What about the parallel time then? You have to take the total number of clock cycles of the parallel portion divided by the number of processors. This will give you the parallel time. Imagine all the 16 processors are going to execute at time 0. So when it comes to time 50, all the processors will complete the execution. So how many clock cycles are involved here? Only 50 clock cycles are involved here. So since one processor takes 50 clock cycles, 16 processors will take 16 into 50, which is equal to 800 clock cycles. So this is how we are calculating the 50 clock cycle. Actually, it is per processor clock cycle we can say. Only when you involve all the 16 processors together, you will have 800. When you take only one processor into account, it is 50 clock cycle. So that's why I said when all the processors from 1 to 16 are going to start from 1 or 0, something like that, when the time is going to be 50 clock cycle, the task will be over and this part will be taken as the parallel portion of the task. Now we know serial time is 200 clock cycle and parallel time is 50 clock cycle. Now let's get into the question. How many total clock cycles are required to complete the task? The total clock cycles will be equal to the serial time plus parallel time per processor. That's what I told here. What is the serial time? It is 200 clock cycles. What is the parallel time per processor? It is 50 clock cycles. So on the whole, we'll have 250 clock cycles to complete the whole task. Option number 1, 250 will be the right answer. Next question. A CPU has a 5-stage pipeline with the following stages: fetch, decode, execute, memory and write back. Each stage takes one clock cycle to complete. Assume there are no pipeline stalls and the pipeline is initially empty. How many clock cycles are required to complete the execution of 10 instructions? This is with respect to one instruction we can say. Fetch, decode, execute, memory and write back. We have a formula to do this, but before seeing the formula, let's understand the scenario and try to compute the clock cycles that are required to complete 10 instruction execution. After that, we will just substitute in the formula and check whether we have worked it in the right way. Let's take the 10 instructions together. What about the first instruction? How many stages it has to go? It has to go for fetch, decode, execute, memory and write back. So the first instruction is going for 5 stage here. They have given every stage takes only one clock cycle. So every cell here can be taken as one clock cycle. Now the second instruction will start from this point. The third instruction will start from this point. The fourth one, the fifth one, the sixth one, the seventh one, the eighth one, the ninth one and the 10th one. When instruction 2 is in fetch, instruction 1 is in decode. When instruction 3 is in write, instruction 4 is in memory. There is no overlap occurring. Every stage is occurring individually here. Now we have to find the total clock cycle. If this is going to be one clock cycle, we have to count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14 clock cycles are required to complete the execution of 10 instructions. How many clock cycles do we need to complete one instruction? We need 5 clock cycles. One for fetch, one for decode, one for execute, one for memory and one for write back. Now we have a formula for this. A K segment pipeline with a clock cycle time TP is used to execute n task. To complete n task using a K segment pipeline, it requires K plus n minus 1 clock cycles. So here the first task is K into TP and n minus 1 task is n minus 1 into TP. So why have they not mentioned TP is given as 1 clock cycle. It is the clock cycle time they have mentioned. So it is 1 clock cycle. Anything into 1 is going to give you 1 only. How many stage pipeline it is? 5 stage pipeline. This is what they have given as K segment. It means it's a K stage pipeline we can say. So K is equal to 5. What about the number of instructions? That is what we have mentioned as n task, where n is equal to 10. So clock cycles is equal to K plus n minus 1. What is K? It is 5. What is n minus 1? It is 10 minus 1. 5 plus 10 minus 1 is 9. 5 plus 9 is equal to 14. Did we get 14 here? Yes. Option number 2, 14 will be the right answer. This is how in the reference book they would have explained you, and from there they would have given the formula K plus n minus 1 into TP. Next question. A vector processor with 16 lanes can perform an operation on 1024 elements with each operation taking 5 clock cycles. How many cycles are needed to complete the operation? Now let's understand what is a lane. A lane is the name of the unit that is used to describe the width of an execution unit. So just imagine the car lane or the transport lane that we used to see in the roads. So there will be different lanes like this. It will have some kind of width that describes the width of an execution unit in this context. These are the 16 lanes. So 16 lanes will perform on 1024 elements. You have to split 1024 by 16. So when you divide 1024 by 16, you will get 64. So 64 here, 64 here, 64 here. Similarly, this is how it will be divided. So 64 into 16 will give 1024 elements. So 64 elements will be processed in one lane. How it will be processed? It will be processed from V0 to V63. It means when you take the first row, the 0th row, they have told one operation will take 5 clock cycles. This is the first operation we can say. This will take 5 clock cycles. So for this operation, how many lanes are involved? 16 lanes are involved. When V of 0 is taken, it is executed in 16 lanes together. This one row is actually called as one cycle. Then how many rows do you need to make it for 1024 elements? If you execute 0, at a time we are covering 16 lanes. When you execute the first row, you will cover another 16. So how many times if you multiply 16, you will ultimately get 1024. You have to multiply 64. It means there are 64 rows involved here. So number of cycles, otherwise it is called as operations. This is equal to 1024 divided by the number of lanes, which is equal to 64. Option number 1 will be the right answer. So you can take this as there are 16 lanes which are columns. There are 64 cycles which are rows. Altogether you will have 1024 elements as mentioned in the question. Many confusions are evolving, like whether this is number of operations or number of clock cycles. The CPU clock cycle is the fundamental timing mechanism. The CPU cycle refers to the entire process of executing an instruction. So here we can equate this to one row is one instruction, and this happens in 16 lanes simultaneously. This may span several clock cycles. So here this one instruction can be equated to one operation, and this one row is executing in 5 clock cycles as per the question detail. So here cycle is nothing but the process of executing an instruction, the operation they have asked. So this question is clearly asking for the number of cycles, number of operations. That's why I mentioned here as V of 0, rho is 1 cycle. So how many cycles are there? 0 to 63. Totally there are 64 cycles involved. So that's why I splitted this as every lane is executing 64 operations. When you multiply 64 into 16, all the 1024 elements would have been taken for consideration. So if the question is, how many clock cycles are needed to complete the operation? How many cycles are there actually? 64 cycles are there. How much does one cycle take or one operation take? One takes 5 clock cycle means 64 cycles will take 64 into 5 clock cycles. So overall we will have 64 into 5 which is equal to 320 clock cycles. If they ask about clock cycle, the computation will go this way. If they ask about cycles, the computation should end by here. Next question. Arrange the given steps required for a direct memory access DMA transfer in the correct order. In DMA, the interface transfers data into and out of the memory unit through the memory bus. In this mode, the I/O module and main memory exchange data directly without processor involvement. When the processor wishes to read or write a block of data, it issues a command to the DMA module. The processor gives this I/O operation to the DMA module. So let's take the processor is giving it to DMA module. The DMA module transfers the entire block of data one word at a time directly to or from memory. When the transfer is complete, the DMA module sends an interrupt signal to the processor stating that it has been completed. Thus, the processor is involved only at the beginning and at the end of the transfer. So, in the beginning, it is only initiating the process. At the end, it is getting the control back from DMA module. This first step, when the processor wishes to read or write a block of data, it issues a command to the DMA module. This can be taken as the initiation step, which is in A. The processor gives this I/O operation to the DMA module is what we can see in C. Processor grants DMA control over the system bus. So here it is initiating the request and then it is granting the control over the system bus. The DMA module transfers the data one word at a time directly to or from memory is what statement B is about. Transfer data directly between peripheral and memory. When the transfer is complete, DMA module sends an interrupt signal to the processor is what DMA controller completes data transfer and signals completion. This is D. So A, C, B, D. Option number 2 will be the right answer. Next question. Find the correct sequence of the storage device in ascending order based on their access time. I have two diagrams for this. One is taken from the operating system reference book and another one is taken from computer system architecture reference book. If we see both these diagrams, we can understand that the storage capacity is small in the top level and it is getting larger when we go down the level. Similarly, the access time is fast in the top level. When we get down, it is becoming slow. Since the question is about access time, we will arrange it from fast to slow. The first level is actually registers. In both the diagrams, it is registers. So we can mark A here. Let this be A. What about the next level? It is cache memory. There is no option. Then we have main memory. Main memory is in option D. So we are marking D here. So optical disk is E and magnetic tape is C. What about this diagram? We have magnetic disk here. So it is B. We have CD-ROM, CD, read-write, then DVD, DVD RAM, everything. All these Blu-ray disc, everything belongs to the optical disk part. So optical disk option E can be marked here on behalf of all these names. What about magnetic tape? It is in option C. Now what is the order you get from fast to slow access time? It is A, D, B, E, C. They have asked us to arrange the storage device in ascending order. Ascending order means small to large. What is the small value? It is small access time to large access time. For registers, if you are going to access it in 1 second, for tape you may take 10 seconds. So this is fast access time and this is slow access time. If you go by this order, which is first in ascending order, registers will stand first in ascending order. So ADBEC will be the correct order of this particular question. Access time is fast means it is done in a quick time. It means it takes less time to access. Access time is slow means it takes more time to access. So if this is going to be 1 second, this is going to be 10 seconds. And in between you may have 2, 4, 8. Overall when you take the order, it is ADBEC. Look at the options. You don't have any of the options matching to this particular sequence. But you can find the reverse of the option here. ADBEC. Option 4 is in reverse. Actually they have arranged it in terms of the speed, we can say. So here the access time starts from 1 and here it takes up to 10 seconds as per this option. Since the option is arranged in reverse order and no other option is getting matched to this particular sequence, they have dropped the question. There is no key provided for this question. So this is the answer of this question. Next question. Consider the given number 45 to the base y, where y is the base of the number. Sum of the possible values of y are given below. There is a series going on in this channel, CS Connect series. In that there is a video called number base. It will give a good understanding about number base concepts and even about base conversions. There are videos, you can just check them. If you take a base of a number, what will be the possible values of that particular base? When you take the decimal system, base 10, what are the numbers that are included in decimal system? 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you take binary, it is base 2. What are the numbers involved here? 0 and 1. When you take octal, it is of base 8. What are the numbers involved? 0 to 7. When you take hexadecimal, it is base 16. What are the numbers involved? It is 0 to 9 in decimal. Then we have 8 to F, which is nothing but the denotion of 10 to 15. So it is between 0 and 15. Whenever you take the base, it starts from 0 and ends to the number before the base. So now we have to check the numbers for base 5, base 6, base 7, base 8. So let's take the base r digits that range from 0 to r minus 1. So if it is base 10, we end up with 9. If it is base 8, we end up with 7. Let's take base 5. It means it should be from 0 to 4. When it is base 6, it will be from 0 to 5. When it is base 7, it is from 0 to 6. When it is base 8, it is from 0 to 7. When you are writing a number using this base format, whatever number is allowed here, that alone will be enclosed in the brackets and given the base. Say for example, if there is a number 87 to the base 8, this is wrong because 8 is not a valid number of base 8. It has value only till 7. When we say BZ is a hexadecimal number, it is not possible because the values are available only from A to F in letters. There is no value called Z. Similarly, when I say there is a number called 1, 2 with base 2, it is not possible because when you take base 2, you have possibilities of only getting 0 and 1. 2 cannot be the number of base 2. Number 4 is there. Is it a possible value in base 5? Yes, it is a possible value. 4 is there. 4 is there in 6. 4 is there in 7. 4 is there in 8. What about the next digit 5? 5 is not there in base 5. But 5 is there in base 6, base 7 and base 8. What are the possible values of y? If y is equal to 5, 45 does not exist. If we say 4 5 to the base 6, 6 is included. 4 5 to the base 7 is also available. 4 5 to the base 8 is also available. All these three bases can be taken. Option number 2. B, C and D only will be the right answer. When there is a base 5 number, the digits will range only between 0 to 4 and definitely 5 is not there. Next question. Consider the following statement regarding special purpose registers. They have given 4 statements. Choose the correct answer from the options given below. So we have to choose the correct statement. The list of registers for the basic computer is taken from the reference book. Here we have program counter, then we have instruction register and we have accumulator here. So they have just given what kind of work it is going to do. The program counter holds the address of the next instruction to be read from memory after the current instruction is executed. So this is what they say, it holds the address of instruction. So the first statement, program counter keeps the track of next instruction executed is perfectly fine. Next, the instruction register holds the address of first instruction to be executed. The instruction register contains 8-bit opcode instruction being executed. It is not about the address of first instruction, so B is wrong. Anything that involves B can be ruled out. Next we have accumulator holds the output of ALU. The accumulator is used to hold temporarily operands and results of arithmetic logic unit operations. This statement says that C is true. What about the fourth statement? Program counter keeps the track of only first instruction of the program. It holds the address of the next instruction after the current instruction is executed. So it is not about tracking only the first instruction. It's about tracking the next instruction to be executed. When A is true, definitely D is false. So when you find D is also false, you can rule out option 2. Option number 1, A and C only will be the right answer. Next question. Consider the following statements regarding combinational and sequential circuits. So they have asked about the output of combinational circuits and output of sequential circuits. A combinational circuit is a connected arrangement of logic gates with a set of inputs and outputs. So this is the diagram. If there are n input variables, there will be m output variables. The outputs at any instant of time are dependent upon the inputs present at that time. Just based on the input, the output is being given here. And it's just an arrangement of logic gates. So as soon as you pass the input, you will get the output immediately. So let's see A. Output of combinational circuits depend on the only current input. That is what this statement is specifying. It is right. Output of combinational circuit depends on both current input and previous output. It has not mentioned anything about it. The previous output is nowhere taken as input here. So this point is definitely wrong. A is definitely true. So we will rule out 3 and 4 here. Now what is sequential circuit? A sequential circuit consists of combinational circuit to which memory elements are connected to form a feedback path. When there is a feedback path, it means you get output here. From this output, something is entering as an input here. So this is what they say. The previous output is also fed as an input here. If this is going to be the case, output of sequential circuit depends on both current input and previous output is right here, and this should be wrong. It's because this will be the current input and this will be the previous output that is getting connected back to the input path here. This is what they call as the feedback path. So here D is also right. We will rule out option 1. Option number 2, A and D only will be the right answer. Next question. Match list 1 with list 2. List 1 is about the counter. List 2 is about the uses or its working. We have n-bit ring counter, synchronous counter, asynchronous counter and decimal counter. From the term decimal counter, we know it is going to involve only the decimal digits 0 to 9. Decimal counter ranges from 0 to 9 and binary counter is about 0 and 1. Based on this idea, we can map D to 3. D3 is available in 3 options, so the second option can be ruled out here. Next, we will see about ring counter. Ring counter is the simplest shift register counter that uses an n-bit shift register to obtain a counter with n states. How many bits are involved? Those many states are involved. You have to take this clue from the statement. N-bit ring counter will be mapping to counts exactly n states. A is mapping to 2. Still, we have 2 options here. So, we can rule out even option 4. What about synchronous counter? It connects all of its flip-flop clock inputs to the same common clock signal. When they say something as same common clock signal, you can equate it to universal clock. So, synchronous counter will be mapping to option 1, uses universal clock. This is what they have mentioned as the common clock signal that is mentioned in the statement here. Then what about asynchronous counter? The main clock is applied to first flip-flop only. That's why we have the term asynchronous. So, C will be mapping to 4. C4 and D1 is available in option 3. Option number 3 will be the right answer. We have also ruled out option 1. Next question, match list 1 with list 2. List 1 has the computing systems and list 2 has either the working or the output. Half adder, decoder, register, main memory. A combinational circuit that performs the arithmetic addition of 2 bits is called as half adder. We get a clue here, arithmetic addition of 2 bits. So 2-bit addition circuit is the answer of half adder. A will be mapping to 4. A4 is available in 2 options here. We will rule out the other 2. A decoder is a combinational circuit that converts binary information from the n-coded inputs to a maximum of 2 power n unique outputs. So, when there are n inputs that are converted to 2 power n output, this is a decoder. What about the encoder? It is just the reverse. 2 power n inputs are applied to get n outputs. So, decoder can be mapped to 1 has n input and 2 power n output. B will be mapping to 1. So, we can rule out even option 2. What about register? A register is a group of flip-flops with each flip-flop capable of storing 1 bit of information. This can be equated to CPU storage unit. C will be mapping to 2. What about main memory? The main memory is available to the user for storing programs. The contents of main memory may alter. It means it may change when the data are manipulated and every time that the program is changed. They say it is used to store program at runtime. The contents of main memory keep changing is what they say at runtime. The contents may alter when the data is manipulated or when the program is getting changed. And so we can map main memory to used to store program at runtime. D will be mapping to 3. Option number 3 will be the right answer. With this, we are completing Unit 2 solutions.